Today we will discuss the structure of oxide of chlorine. In previous lecture, we have discussed the structure of oxide of aluminium, the structure of oxide of phosphorus, sulfur, and sodium and magnesium. Today we will discuss the structure of oxide of chlorine. Chlorine forms urine oxide. We were discussed only two of them. One is chlorine monoxide and other is chlorine 7 oxide. In chlorine monoxide, the chlorine in +1 oxidation state, while in chlorine 7 oxide, the chlorine is in +7 oxidation state. First question is that why chlorine here is in plus oxidation state even though chlorine is more electronegative. This is because oxygen is more electronegative than chlorine. When chlorine are directly attached with oxygen, then it shows positive oxidation state. In the two oxide, in the Cl2O, the chlorine in its minimal oxidation state means at +1, while in Cl2O7, the chlorine is in its maximum oxidation state, that is +7. In chlorine monoxide, the chlorine uses its one electron of its outer shell. So it shares one electron with oxygen, and in this oxide, the oxidation state of chlorine is +1. And this is the structure of Cl2O. Now, the chlorine 7 oxide. The chlorine 7 oxide is a colorless oily liquid, while the chlorine 1 oxide is yellowish red gas. Chlorine 1 oxide exists in gaseous form, while the chlorine 7 oxide exists in colorless oily liquid at room temperature. In this oxide, that is in chlorine 7 oxide, the chlorine uses all of its outer electrons, which are 7. It is chlorine uses its 7 outer electron for forming bond with oxygen, and they produce a bigger molecule, and the attractive force between bigger molecule are stronger. That is why it exists in liquid state. And this is the structure of chlorine 7 oxide. This is the structure of chlorine user. Every chlorine uses its 7 electron, mean 2 here, 2 here, 2 here, and 1 here. Now we will discuss the acidic and basic behavior of the oxide of third period element. In third period, when we move from left to right, the acidic strength of the oxide is decreases, while the basic strength is decreases. Acidic strength increases while the basic strength decreases. The left side, the oxide of left side metal elements are basic in nature, while that of right side elements are acidic in nature. In the middle, aluminium oxide, it is show impuritism. They are impuritic in nature. So the trend in acid-base behavior is shown in various reaction, but a simple summary, the trend is from strongly basic oxide on the left-hand side to strongly acidic one on the right side through an impuritic oxide in the middle. Impuritic oxide we will discuss later in this lecture. So now we will discuss the acidic and basic behavior of these oxide one by one. Reaction of oxide with water, acid and base, and we will study the chemistry of individual oxide. The first one is sodium oxide. When sodium react with oxygen, they produce sodium oxide and sodium superoxide, sodium peroxide. This is normal superoxide. And sodium oxide simply stronger, strongly basic oxide. Basic oxide means when they dissolve in water, they produce basic solution. They react with acid to produce salt and water. Now the question is that why sodium oxide is basic in nature? The answer is that it is because why sodium oxide is basic? It is because it contains O2 minus ion. O2 minus ion, which is a very strong base with high tendency to combine with hydrogen ion. Oxide ion is strongly basic because it easily accepts hydrogen due to its negative charge, and they produce OH ion. And OH ion show the basic behavior in a solution. So we say that sodium oxide is a basic oxide because it produces O negative ion which combine with hydrogen to form hydroxyl ion, a basic ion. So we discussed the reaction of water with sodium oxide. Sodium oxide react exothermically, means it is released with cold water to produce sodium hydroxide solution. In A2O, it react with H2O, it produce NaOH. And NaOH is a base, is an alkali. Alkali means the soluble base, the base which is soluble in water. Such base is called alkali. When you react with sodium with water, the solution become alkaline in nature. This can be tested by dropping a few drops of naphthalene in it. If its color change to pink, it means that the solution is alkaline. Mean when you react sodium oxide with water, the solution become alkaline, and it can be tested by using phenolphthalein is an indicator. Now we will see that how sodium oxide react with water. This is water. We take it in a test tube, and this one is sodium oxide. We drop some sodium oxide in it and dissolve the sodium oxide in water. This sodium oxide react with the water to produce sodium oxide is already discussed now. Now we can test the solution, is it is basic or not, is NaOH is produced or not. We are shaking the mixture to complete the reaction of sodium oxide with water. When the reaction is completed, it's when the sodium oxide is dissolved completely, then we test. Now we test the solution for acidity and basicity. Is the solution become basic or not? This is phenolphthalein indicator, which changes colors from colorless to pink in basic medium. Now you see the solution become pink. It means that sodium oxide react with water to produce sodium hydroxide. So you see that sodium react with water to produce this one, and we can test it by using naphthalene. Reaction with acid. As we discussed here, the sodium oxide is basic in nature. So when it react with acid, they produce salt in water, because when acid react with base, they produce salt in water by the reaction of neutralization. Now you see, this is Na2O, sodium oxide. When it reacts with HCl, they produce sodium chloride in water. Sodium chloride is salt, and so this is simply neutralization, which show that sodium oxide is basic in nature. Magnesium oxide. Magnesium oxide is also metallic oxide, and it also basic because it also contains oxide ion. We simply say that metallic oxide are acidic in nature, while non-metallic oxide are basic in nature. Magnesium is metal and metallic oxide, so magnesium oxide is basic in nature. but it is not so strongly basic as compared to the sodium. It is basic. Why? Because it contains oxide ion O minus 2. But it is not strongly basic like sodium. Why? Because here the oxide ion are not free as in sodium. There are two questions. The first question is why magnesium oxide is basic? The answer is that because it contains oxide ion. The magnesium oxide is not strongly basic as compared to the sodium oxide. Why? The answer is because the oxide ion are not so free as in sodium oxide. Now the third question, why the oxide ion in magnesium oxide are not so free as compared in sodium oxide? The answer is that in the sodium oxide case, the solid is held together by attraction force between +1 and -2 ions. While in magnesium oxide case, the attraction are between +2 and -2. So here the attractive force are stronger than sodium oxide. That is why the oxide ion are not so free. So it takes more energy to bring these attractive forces. That is why they are not so strongly basic as compared to the sodium oxide. Now, reaction of magnesium oxide with water. The magnesium oxide is basic oxide. So when we treat it with water, it also produces alkaline solution. It also produces basic solution, which can be tested by using indicators, which we can test by using indicators. Now we can see how magnesium oxide reacts with water. This is magnesium ribbon. When we burn it in the presence of oxygen, it produces magnesium oxide, as we already discussed in the previous lecture. This is the burning of magnesium ribbon. It produces magnesium oxide. And we treat the magnesium oxide with water. It produces magnesium hydroxide solution. And we can test this magnesium oxide, this solution, by using this litmus paper, indicator paper. If it is basic, it will change the color of red litmus paper. This is the addition of water with the magnesium oxide. Now we take some magnesium oxide solution and pour it on the litmus paper. No effect on blue, while the red litmus start changing to blue. This means that the solution is alkaline, which clarify that the substance formed here is magnesium hydroxide. So we say that magnesium oxide is also basic, so it produces a basic or alkaline solution when it dissolves in water. Reaction with acid. If magnesium oxide is basic in nature, so they react with the acid to form salt and water. So they produce magnesium chloride and water. Now the third one is aluminium oxide. As in the start of the lecture, I told you that as we moving from left to right, the basic character of oxide of third period element decreases. So the first two are basic in nature. Now the third one, aluminium oxide, is an amphoteric oxide. Amphoteric oxide mean that they show the behavior of acid and base depending upon the reaction condition. That is, when they are reacted with acid, they act as a base. When they are reacted with the base, they react acid. And when they reacted with acid, they react as a base. So, with this reaction with water, aluminum oxide does not react with water simply because it does not dissolve in water. It does not dissolve in water, so it cannot react with water. Although it contains oxide ion, but their tendency to react with water are not so high, so they cannot react with water. Reaction with acid and base is as I already told you that aluminium oxide is amphoteric in nature, so they act as an acid and also act as a base. So they show both the behavior of acid and base. When we react aluminium oxide with the acid such as H2SO4, they produce salt and water. This reaction shows that aluminium oxide is basic in nature. When it reacts with the acid, it produces salt and water. While if you react aluminium oxide with sodium hydroxide, then they act as a acid. And again, it produces salt and water. This is salt and this is water. This reaction shows that aluminium shows the behavior of acid. While this reaction shows that here aluminium oxide act as a base. So we say that aluminium oxide is amphoteric in nature. It is enough for today. And thank you all.